Hello, fifth grade. We're going to go over Science 6.6. This is your Tuesday lesson. The pages are 168 through 171. So please make sure that you are reading these sections first, then watching the videos, and then taking any notes additionally that I may have on the board or to help you with those notes. Also, we do have Quizlet available, so you should be going ahead and checking out Quizlet every day too, or every couple of days regarding these sections as well, just to make sure that you're understanding what is going on. Okay, so today we're going to be talking about the power of internal combustion. Now, Mrs.Lawler is not a genius when it comes to engines, so this is going to be a basic format, and I'm also going to provide you with a couple of videos to watch as well, because I know that their explanation of something might be better than mine since I'm not with you. Okay? So, one, I want you to start off with knowing that combustion is just another word for burning, okay? Combustible means it burns. Non-combustible means it doesn't burn, okay? So, fuels such as wood, gasoline, oil, coal, those are combustible materials or things that fuels that is used as fuel, right? But fuel must have oxygen in order to burn. So now, if you were to light a fire and put a bucket over it and seal it in something, eventually all the oxygen would end up being used up, and then it wouldn't be able to burn anymore. So oxygen, that's why we put a fire pit, and we make a nice big fire pit when we're camping, and we put the fire in the middle, and we don't cover it or anything because we need it to burn. Just like fire pits, like those ones that stand up and you camp at, and then all the fire is in there. It's open because it needs that oxygen to burn. Okay, so don't forget that. Fuels must have oxygen to burn. Okay, so we have two types of engines. We have an internal combustion engine and we have an external combustion engine. Now, an internal combustion engine burns fuels inside the engine, and the external burns fuels outside the engine, kind of like a steam engine. And we watched that video about the steam engine. Okay, so we have chemical energy, and that there's actually different types of energy. So first we have the chemical energy, and that's potential energy that is stored in fuels, and it's actually released when it's burned. Okay, so we have our our wood, right? And so when we have our steam engine, when we burn the wood actually heats up the water that was around those coils, and then the coils heat up the water, and then the water produces the steam as it's boiling, right? When it gets to boiling point. And then when it gets to boiling point, it then produces that steam, and then that steam is what pushes and goes down and ends up pushing the pistons, right? Okay, so basically, when things are burned, they may turn into light energy, or they may turn into heat energy, okay? So the bonfire is heat energy, right? As the wood burns, we get that heat energy and we use it. It also is light energy because we can see with the light, right? But when we transfer the heat energy to kinetic energy, which makes things work, like in the steam engine, and it's able to heat everything up, which then pushes something to then turn the piston and then turn the wheel, that's when we're using that potential energy and turning it into kinetic energy. Okay, remember learning about that? Okay, now automobiles have an internal combustion engine. Now that means that gasoline is compressed within the cylinders of the engine, and the gasoline is graded on their ability to explode sooner or more sudden. Yes, actually it explodes inside the engine. I'm like, my mind is exploding. Okay, so it's all internal, so your engine doesn't blow up every time, but inside it actually has a small explosion. So now when you want the gasoline to burn smoothly, that is called anti-knocking quality. So basically what that means is when the fuel burns smoothly, you don't have knocking or pinning noises. But when it isn't burning as smoothly, then you might have these knocking noises. So the octane number is actually that 87, 89, or 91 that you see at the gas station pumps. That is telling us the quality of the anti-knocking, meaning the octane number is showing us the anti-knocking number or quality. So basically, the higher the number, the better the anti-knocking, meaning it doesn't knock. The lower the number, then the more regular, like on 87, most people use 87 for regular, it might knock a little bit more. And that means that when it's knocking, it's exploding too fast or not at the right time. And you want everything to run smoothly when it's exploding the way that it needs to explode. So, if it explodes at the wrong time, it's wasting energy, and that's something you don't want to do. You want it to be running smoothly and exploding at the right time. That's why we have the different levels for the different engines. Okay, so now there are two types of engines. Okay, there is the car engine that we have that's called a 4-stroke cycle, and then we have the diesel engine. So what I want you to do is you're actually in just a minute going to go ahead and watch a little bit more about that car engine on an extra video on how the 4-stroke cycle works. So there is 4 strokes. The first stroke is the intake stroke. The compression stroke is number 2, the power stroke, and then the exhaust stroke. So there's 4 strokes in a 4-stroke engine. That's why it's called that. And I want you to watch that video to explain how the explosion works on the inside of the engine by compressing, okay, the oxygen that's coming in, and by burning the fuel, and how that ends up pushing on the pistons, which then push on the shafts, which then go ahead and turn things in the engine, which then goes to the drive shaft and all that kind of stuff. So I want you to go ahead and look at that video. But what I want you to know is there's another engine too. So there's the car engine, and then there's the diesel engine. Now they run very, very similar. However, when you watch the video, you'll see that the car engine actually uses a spark plug to ignite, and it actually catches fire and explodes that compressed gas, right? And then that's what explodes. But in a diesel engine, they don't actually use a spark plug or a spark. What it does is it heats up way hotter than the other car engine can, okay? And so when it heats that up so hot to like 900 degrees, even up to like 4,500 degrees, it actually combusts on its own and catches fire on its own. And so you don't have to use a spark plug for that. Now, diesel engines are mainly used for machinery, high machinery like tractors, and obviously those big diesel pusher trucks, right, that are pulling big loads. So that's when we use diesel engines instead of regular car engines, because it needs to have more power, and they don't want to keep replacing spark plugs to keep that spark going all the time on that heavy load. So they end up using a diesel engine, which can get hot enough, and it will end up producing that explosion on its own. So go ahead and take a look at that. Let me see, did I go over everything? I went over combustion, another word for burning. Fuels need oxygen to burn. Our octane number measures the anti-knocking quality in our gasoline. And so go ahead and take a look at that other video, because it may be, I might put 1 or 2 on there so you can see it, to see how things work and how it turns everything and how it explodes inside the engine. It's just another way to look at that diagram at the top of page 170 in your book. So it will explain a little bit more. And don't forget, take some notes on this and then make sure that you are studying these things and learning. And I will see you tomorrow for science.